Okay. Hi everyone. Welcome to today's KubeVela meeting. Today I will have a topic. I will share the latest QX feature that is already merged in master branch, but some of the new optimization hasn't merged yet. But we're gonna release the next 1.10 KubeVela version in I think the end of this month. So gonna I'm gonna share the slides. Wait a second.
That's awesome.
Yeah. Can you see my screen?
Yes, we can.
Okay, great. This is actually the slides that I'm gonna share on the KubeCon Hong Kong in the next week. All right, so the first thing is I want to explain why we need to use QX for this refactor. So in our previous, the old way, in all of these Q definitions, if we are using the Vela/OP in package, you're gonna realize actually we will first mix of all the params and the returns value. For example, the typical OP dot apply, uh, you're gonna need a value as a params, and also the value will be your returns after the apply action got executed. So it's quite confusing. And it will also override the existed value. And we do a lot of hack things to make sure the value is overridden. And it is very hard to understand and maintain in our code base. And also, the old way has no modules. So we're gonna need everything under Vela/OP, which is include all of our packages, and the naming is quite confusing as well. And also, in this old way, we cannot register our own providers. We can only use KubeVela's built-in providers. So in order to fix this, we're gonna release QX feature. So this is the architecture of QX. We're gonna have a compiler, and the compiler is the entry uh, for your Q files to be compiled. And all of our providers, they're gonna be the package, and the package will be registered to compiler. So you can either the compiler can not only register the KubeVela's built-in packages, but also the user's custom packages. And inside of the code base, we will have some provider functions for you to execute the providers. For example, the internal package will be like some base packages like base 64, HTTP, cube, etc. And this is how the Q definitions looks like after this QX refactor. So first, a typical provider, they will need like four things. The first thing is the do. Do means do actually links to the Go function name in our KubeVela code base, and the provider is just the name of the provider. And the params means the provider needs parameters to be executed, and the returns will be filled in with all of the return values after the provider is executed. So it's quite like a function call, and we want to make it simplified, just all link params and returns, so that users can easily to understand those two things. And on the right side, there's a usage. So for example, the HTTP package is now naming as Vela/HTTP. And also, for example, you want to a GET request, you can just call the http.get and have a params, which is a URL. And when you want a return, you can use request dot returns to get all of the return values. And also, if you want to register your own packages, we will have a custom resource called package. And in this package, we're gonna need the path of the package, and also the provider currently will only support HTTP protocol. So in our design, we're gonna also need support other protocols like what's it called? Other protocols, but right now only HTTP. And the endpoint is the where your this package serves. For example, the service name inside of the Kubernetes cluster. And the templates is just the actual templates that this provider provides. For example, this MySQL package gonna have this list table capability, which will actually call the list tables function inside of this endpoint. And it also has a params and returns. And after you register this package and you want to use in your own definitions, you can just import this external /db/MySQL, which is the spec.path in your package, and then just call the package as you want, like the params, and got the returns. Yeah, I think that's basically how it works. And so, any questions?
Yeah, Fog, if you go back to the previous slide, yeah,
Which one?
two down, 21.
21. Okay.
Yeah, so here's where we register external packages, right?
Yeah.
I'm not sure I understood entirely. What does the endpoint here mean?
Oh,
Endpoint is a multiple endpoint, or is it a function endpoint or something?
uh, it's actually where your service can provide this package. So if you have a Rust service in the Kubernetes, and then
Uh-huh.
because the protocol here is HTTP, so we need this Rust service to expose an HTTP service so
Got
that
it.
the controller can call this service.
So this is a Kubernetes service,
Yeah, Kubernetes service. And also if you want
mostly.
like the external HTTP service also, it will be fine.
Got it. Okay. Anybody else? Guidewire, I think this is exciting. We can extend this, and I think we'd probably start with external packages before we can contribute back into KubeVela.
Could you go over the providers again, and what they mean in this stack online, I guess, on slide 19? You have providers on slide 19. Could you kind of explain those again?
Like those providers, where is?
So you have the provider block on the bottom of the stack here?
Oh, this one, generic. This provider. Uh,
Yes.
yeah. So this is what we called this is actually just a naming. It's like it's more like you can understand it as function. The provider is just what we call it in the KubeVela code base. You can also understand it as a function. It's just a function to provide those capabilities.
So it says a handler to execute Q dot value. So when you say it's just a function, are you saying it's just a function to execute these packages?
Um, so it's more like for example in here the provider is like MySQL, and the do is list tables. So basically, if you are using Go, then you're gonna have a file, maybe a package file called MySQL, and inside of these files, you're gonna have different functions called like list tables, read tables, delete tables, something like that. And the the whole thing we call it a provider, and the provider is MySQL.
I see. Okay, thank you.
Okay.
Awesome. So another question, Fog. I think we've already merged the QX changes. Now you're working through converting from the old OP provider to spreading it out, right? Is that the PR that you've been working on right now?
Yes, I'm currently fixing the tests. Yeah.
Got it. Okay, awesome. Cool, this is great. Fog, if you have time, since we already have some more time, the team in Guidewire was working on the versioning uh, for components, and they'd like to talk about that so that they can take feedback from you and anybody else in the community.
Yeah, great.
Okay, I will
All right.
share.
Srijit or Shreyas or Kanchan, do you know who's presenting?
Kanchan will present that one. Yeah.
Okay.
Yeah. This is the key to support versioning for the KubeVela components. Currently, in KubeVela, when we create a component, it creates a definition revision, and we can refer that revision in the application. And this versioning scheme has some issues, like we can't identify the type of the version, like whether it's a patch or bug. And second thing is, if it doesn't provide the revision number in the component, revision number of a component in an application, at the reconciliation time, it will pick up the latest component version available in the cluster. So we are trying to add a semantic versioning support for a component and allow pinning a specific and non-specific version of a component in an application. So currently, when we create a component without an annotation, definition revision.om.dev.name, it will create a definition revision and add a revision number as a 1, and it will add a prefix 1 v1 into a definition revision name. If we update that definition component, it will auto increment the revision number to 2, and similarly, it will add v2 as a suffix into a component definition revision name. But if we use the annotation while creating a component, it will use that value of annotation to create a definition revision number. It will add that as a suffix, and the revision will be incremented. So we can use both name revision and the definition revision in the application. So it can cause some problem in maintaining the consistency across the cluster. And another thing is, when we update the component and the component doesn't have a name revision, then it will name annotation. It will auto increment the definition revision and create a new revision. But if the name annotation is present and it's not updated, but the spec of the component is updated, it won't create a new definition revision. So this behavior is inconsistent. So we are proposing two ways. In the first way, we can add a version annotation. It will work similar as a name. Name annotation we saw in the previous one. So, but the issues with this will be, there will be no clear, distinct way to identify the revision generated by the name and the version annotation. So, the KubeVela developers will have to keep a track of the revisions created before and after the rollout of this feature. Also, if both annotations are present, name and revision, then we'll have to decide how the revision will behave. Second proposal is to introduce new API version v2 beta 1 of a component definition CRD. So this will allow to refer a component definition using a semantic version. And to manage the versions of a component, we are planning to use a Kubernetes API model. And we can refer that component in an application using a syntax like component name and the revision name. So the new CRD will look like this. It will have two versions. V1 beta 1 is the existing version. V2 beta 1 will be the new version. We can create a component using the new version like this. change the version here. And in the spec, we will have a new field versions, which will be the array of all the versions of a component. And we can create a component using the above component. We can create the application using the above component like this. A component name at the rate, the version name. So currently Kubernetes supports storing only one API version of a CRD. So we are thinking of storing the older version, V1 beta 1. And when user creates the component using the newer version, we will have to translate it back to the older version before storing it into a database. For that, we are planning to use a conversion webhook. So we will have to add a conversion webhook into the CRD also. So it will look like this. And since we are thinking of storing a older version to store into a DB, we have to mark storage true for the older version. And we are thinking of storing older version because we don't need to migrate the existing component to a newer version as a part of a KubeVela upgrade. Plus, it will be backward compatible and it's advisable to store the stable version. Any questions till this point?
One comment, should it be V2 beta 1 or V1 beta 2?
I was thinking about V2 beta 1 because the spec of the component is changing drastically. So whatever in the spec was currently, it's going into a versions array. So that's why, but we can go back to the V1 beta 2 also.
The idea was, Anup, that because V1 is already in beta, right? So this would be a drastic change in the spec. We could technically continue with V1 beta 2, but preferably if we are going to follow the conventions, at least how Kubernetes details it, V2 would be the ideal one. And we can't do V2 alpha 1 as well because there is a weird comparison behavior, which will always rate the beta ahead of alpha, whether it is V1 or V2, doesn't really matter. So alpha is always rated below beta. So that's why for the time being, it's discuss it like there's no hard line here, but that's why we are going for V2 at this point.
Interesting. Sorry, Fog, we're primarily looking for your feedback or input.
Sorry, I'm still going through this whole doc. I have a question. And why are we gonna upgrade the? Why are we gonna change the component definitions CRD?
Because we are planning to use a versions array. We are planning to introduce a new field versions to store all the versions of a component, and it's changing the spec of the component definition CRD.
If we're
So
just adding a new field, we can instead of changing it, then we can still use the old version, right? Because we're not gonna like change the old customer resource. We're just gonna adding some new fields.
So generally it is, I might be wrong, but when I was reading it, so it was saying that if we are changing the spec of something, we'll have to use a different API version.
Fog, I think the major change here is not just adding a field, but currently as it stands under the spec, we just directly go into the schematic. Right now, what we are introducing is a versions array, which does not currently exist. So the versions array that you see is not there right now. So what we are doing is currently putting all the, whatever is in the current V1 beta 1 spec, and putting that into an array, which will be multiple copies of that. So right now, under the spec, you directly go into the schematic.
Yeah.
As part of the new API, we will have a new versions array, and the schematic will go within the array, that array.
Yeah.
But
So
in theory, as long as we make versions optional, we don't have to version the CRD.
But we are introducing the spec, the schematic will go inside the version actually. We can't directly add schematic in the spec.
But if you supported both.
Yeah, we
Yes.
are supporting both. We are supporting both. So yeah, that's what we are gonna discuss. And even we are storing the older version in the database, not the newer version.
I'm saying if you support both, specifying versions like that and just the individual schematic, like the current state, you wouldn't necessarily need to version that component definition CRD. You could just introduce a new optional parameter on the CRD without versioning.
Okay,
Yeah.
but we were trying to follow the Kubernetes API versioning model, like in the CRD, we get a versions field here, and that has all the versions specified. Like we take an example of CRD, we get a versions added, and all the versions supported will be listed here. So we wanted to do something similar for the component also. So all the
Right.
versions of the component will be in the same file.
I was just calling out if Fog had concern about us versioning this CRD. It's not completely necessary that we do that. If we make that versions field optional, we don't have to version the component definition CRD.
Yeah, I agree.
Right, because it wouldn't be breaking change.
So we just have a top level schematic, and along with that, the optional versions, which include schematics inside of it.
Right, it's just an option. We could go either way.
The idea here, because we looked into the implementation, the problem comes during the implementation and more specifically maintaining backward compatibility. Because otherwise, what we'll have to do if we go that route that we just introduce a version field within the current schematic, what we'll have to do is you either go one like the old versioning scheme, and if you switch to the new versioning scheme, you go only that way. You can't keep both, because that just makes it messier, because the current versioning scheme is already a little confusing, that the definition revision behavior is a little inconsistent, and we didn't want to add to that.
No, but in the controller, if you are, if there is the presence of versions, then you follow the new path. Otherwise, you just continue with the old path, right?
Yes, but we'll have to treat older version components again. So the components can be referred. Okay, so for example, if you add the versions field and the name annotation that exists in the current versioning scheme, that just makes it messier. So
Yeah,
again, this is debatable, but the idea was to, if we can separate out the whole thing, so the new versioning scheme will only apply to the new API version, and we can separate it out at that level.
There's going to be complexity either way, because if you version the component definition CRD, then you need to manage the conversion between those versions. That's complexity that you wouldn't have if you chose to.
actually that conversion complexity is not that bigger, because we tried it, but it, yeah, and it will make a code little bit cleaner, means the cleaner way of identifying the version. So that's why we were thinking about this approach. But yeah, we can think about again the keeping the version field optional.
Perhaps Fog, if that's a big concern for you, then maybe Kanchan and team, maybe we could introduce a proposal 3 and ask for feedback from Fog offline. If that's possible.
Yeah, sure. We can add more details offline. I do have some concerns for proposal 2 because of these migrate things, and also if we're gonna have all of the versions and the Q templates definitions in one CRD. I'm not sure when if it will be too hard to manage in the future, because Kubernetes can have a customer resource in one CRD, because customer resource is not a resource that will be changed frequently, but that's not for component definitions. So I think it's better to manage the definitions in different customer resource instead of all versions in one customer resource. But yeah, we can discuss offline and maybe yeah.
Awesome. So Fog, if you could take a look at this TR, and if you could put your comments on and suggestions, that I think that'd be very helpful.
Yeah,
for
sure.
the-
Okay, should I continue with the proposal too? Means what we are thinking of upgrading and handling the existing strategy, existing component, or
I think
can
since there is significant concern, let's get back to the drawing board a little bit and look at the option of having it in the same CRD. But at the same time, let's also give Fog some time to poke holes if necessary in our design.
okay.
But
I would
I would like to understand the concern of, I think I missed the concern of adding a new version of the CRD. I think what is Fog concerned with that?
before that, sorry, I would like to reiterate, like because we didn't make the full argument, I want to reiterate one additional portion. So as we discussed already, that the behavior as we understood it for the current versioning scheme is a little inconsistent in terms of how the definition revisions get updated. So we didn't want to add to that complexity, or like that
Yes.
behavior, that inconsistent behavior. Additionally, what the target also here is to have some sort of auto upgrade available to the application developers. And if we wanted to include that in the current versioning scheme, that would make it, at least implementation wise, much more confusing. So that was like combining these two concerns. We felt that adding a new API version would be much cleaner.
Yeah, this sort
Thank
of grid. Yeah.
Yeah, but I think we should do that. We should give Fog some time and review the document, proposal, of course, and then come back to us. We can also go back to the drawing board with the findings that we have today. But proposal 3, I'm not sure, Anup, but we will discuss and come back to you on that. Yeah.
Yeah, I also had the same question like Jerome had. Means, what will be the problem in introducing a new version?
I'm sorry. What's the question?
Yeah, so what will be the additional complexity or a problem that might we have to handle while introducing the newer version?
Of the CRD.
Newer version of the CRD.
Oh, I think it's more of manage all of the versions in one CRD.
It will create yeah, sorry.
Yeah, so because I'm not sure if it's, first off, I'm not sure if it's necessary, because we can find some way of just adding a fields and make some rules for the old component definition. So I'm not sure, I'm not fully sure if it's that necessary. And also because because our component definitions change frequently if users are developing definitions. So if we're gonna manage all of the versions in one custom resource, I'm not sure like one time we will reach the max length of custom resource.
Okay. Okay.
You
Actually,
mean
we were
because of the versions in it and restoring the versions, you think that would hit the limit of a custom resource?
Yeah, if we're gonna manage all of the versions and all of these queue templates.
well, if that's the concern, actually we were planning to create a definition revision for each version. And we were planning to use the same number of component limit, right? Currently also, KubeVela has the limit to keep a history of the revisions. So we were planning to use the same thing. So if you see, right, for 2 versions, I created a separate definition revision here. So something similar will happen even if you use a new API version of a CRD. So yeah. So if you just 1 minute, please. So when you create a new version, right, at that time, 2 resources will get created in the cluster. A component definition in a B1 beta 1 format, which was the older version, and it will include in the spec only the latest version from the beta 2 object, and a definition revision, which is already getting created for each revision. It will be the same. It will also create the revision for every version into of a beta 2. And we can also add a limit, which is currently existing, history limit in this.
So in essence, for the array in the component object itself might grow bigger, but it will never, that only will be on the side of the developers or the admin applying that particular component. How it will be stored in the database or in etcd or wherever, that will still be extremely small, because we won't be storing the v2 object ever, because we are only marking the v1 object for storage. The only addition, the list that will be added for the applications to refer will still be in definition revision, and there is already a limit on how many definition revisions can be stored, and when we are planning to keep that limit.
Yeah, so
so the array will be large. So the array will be large, but it will be only on the component maintainer side. In the cluster itself, that array will not be stored as is.
I wouldn't expect that it would be common to maintain and to offer a lot of versions of the component definition at the same time. Like in general, you would want to begin deprecating the old ones and removing them. I wouldn't expect if you had maybe 3 supported versions that you would risk getting close to the max.
I'm sorry, Lina, can you confirm your concern is that we might be hitting the max limit too soon?
No, I'm saying that I wouldn't expect that that would happen unless you're maintaining way more versions of a component definition than you ever should.
And you should in a cluster, agreed.
Right. But that is going to be up to whoever is owning the component definition. If they're not actively deprecating and removing old versions, then it's possible that that could happen.
Lina, there's already a limit for that. I don't recall the number right now, but there's already a auto limit for that, and the older revisions automatically get removed.
Okay.
We can extend the same behavior in the new API version also.
You know what that limit is?
Limit is configurable actually. We can decide that while deploying the KubeVela. It take as a deployment flag.
Okay.
Yeah. And with this feature, we can use, as Rahul mentioned, this new feature also, auto upgrade to the version list.
Yeah, it looks like the default is 2 definition revision.
Yeah. The implementing the auto upgrade behavior will be much easier, because we can then separate out the parsing logic for the v2 components, and we don't have to interfere with the v1 at all. Again, the whole approach was based on the fact that we don't want to break backward compatibility in any form, even after the deployment of this feature.
Yeah, so that's why we were planning to store a older version, not the newer version in the database.
Cool. I think like Sri said, let's give Fog some time to look at the proposal and give her inputs in there, and then we'll go from there.
Sure.
Fog, sound okay?
Yeah, sure. I'm sorry. I should look this ahead of this meeting. Sorry.
No worries. I think perhaps for the next meeting we can make a decision so that the team can then move forward with the implementation.
Yeah, good.
Cool. Anybody else have anything else to ask?
All right. So if there's no other questions, so let's wrap up today's meeting. Okay.
Thank you, Fog.
Yeah. Thank you,
Thanks,
everyone.
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 Thank you.
Bye.
Bye.
Thank you, everyone. Have a good day.